Hello everyone! So today we will go to the new topic which is vector. Before that, let's check our homework first. Okay, so let's start from question number 5. I will be going to explain every questions here, question 5, 6 and 7. If you have already done and you know how to do already, you can skip my explanation. You can just look at the answer and tick on your answer there, okay? If it's not the same, then you do correction, and if you don't understand, then you listen to my explanation, okay? So question number 5 here. Okay, so this question asks you to describe fully the enlargement. So this question, right, they ask you to fully describe, but then it's already an enlargement. They ask you to describe about the enlargement. So to describe about the enlargement, you need to describe what is the scale factor, and you need to know what is the center. Okay, so these two things you have to write it down, and it's 2 marks, right? So let's look at shape A to shape B. Okay, what is the scale factor here? So shape A onto B, you can see that there are 2 boxes here, 1, 2. This one become 4 boxes, so it means that it enlarged 2 times. Okay, it's enlarged 2 times, so scale factor is 2. Or you can see 1 box here, right? Here is 2 boxes, so double lah. So scale factor 2. And the center, to find the center, what you need to do is to draw the line. Okay, you draw a straight line connecting from here, from this point to this point. You draw longer, and then you pick another point. Let's say I choose this point and this point. So I draw a line connecting the 2 points. Okay, and you can see that the center is here. Okay, you can try draw a line from this point to this point, you draw longer, and this point to this point, you draw longer. This will be your center, which is 7, 1. Okay, so tick your answer if correct. If no, then do correction. And then part B, shape A is mapped onto shape C by a rotation 90-degree clockwise center 1, 0. Okay, so let's find out what is the center first. The center is at here, 1, 0. And this is your shape A. You want to rotate this clockwise through this point, so it will go somewhere here. Okay, so we rotate one by one, 90 degree. Okay, so first I will rotate this point. Okay, so you see this, it's a 90 degree until here, like this. You see that? Okay, so this green point will go here. Okay, I'll erase this to avoid confusion. Later, too many things you see here. So, and then this one, it will be like this. You see 90 degree? So it's here. Okay, and as for this point, you see the box, 2 box, 90 degree. So the point will be here. Okay, and this point here. Okay, this is 3 by 2 box, so here will be 2 by 3 box, like this, 90 degree. Okay, so you can see it's a 90 degree clockwise. So I have all the 4 points already, so I connect them. So this is your C, the shape of the C. Okay, this is the answer for part B. Okay, take the answer. And part C, okay, transformation P is represented by the matrix of this one. Okay, so you need to know what kind of transformation is this. Remember, I teach you the method of 1, 0, 0, 1 as your standard. Okay, 1, 0 is here, and 0, 1 is here, right? Okay, your standard matrix here. So 1, 0 will goes to 0, negative 1. So meaning to say that this one will goes to here, 0, negative 1. Okay, and your 0, 1 will go to negative 1, 0. Negative 1, 0 is here. Here will go to here. So when you see this point go here, this point go here, right? So it's basically a reflection of the line. What line? This line. This is y equals to negative x. Okay, you see, it's a reflection, okay, under this one. Okay, so what they want you to do is, they ask you to draw the label of D where your shape A goes through the transformation according to this matrix. So this matrix is a reflection, y equals to negative x, right? So you need to reflect this shape A under y equals to negative x also, and you will find your shape D. Okay, so here you draw a y equals to negative x line, okay, somewhere like that. Okay, so you draw this line already. This is your y equals negative x. You're gonna reflect this shape A. Okay, so this one will go to here. This one will go to here. 2, 1, 2. This will go to here, and this one will go to 3 here. Okay, it's like a mirror. Okay, so you need to draw it out. Okay, I'm gonna erase this, the working. So this is your shape D. Okay, so that's the answer for part C, part 1. And part 2, describe fully the single transformation of P. Okay, so you know that it's a reflection, right? So that answer is reflection under y equals to negative x, or on the line y equals negative x. Okay, so this one mark, 1 mark. Now number 6, shape A is mapped onto shape B by a reflection. Okay, this is a reflection, right? This one. So we need to find the equation of the line of reflection. Means we need to find the line. The mirror line is actually this line. Okay, supposed to use a straight line ruler. So this line, they did not ask you to draw, but then I just draw it out for you to see it's a reflection of this line. And this line equation is y equals to negative 1. So the equation is y equals to negative 1. Okay, horizontal line is always y equal. Okay, so let's look at part B. Describe fully the single transformation that maps shape A onto shape C. So you look at shape A and shape C. A onto C, right? This one. So it's obviously that this is enlargement. Okay, and then it's an opposite direction. Okay, it's an opposite direction here, so your scale factor will definitely has negative. Okay, and your center, how do you find center? Center is you need to connect one point to the other point, you draw a line, and the other point to this point also, you draw it out. And actually here you can draw it also. Okay, so there are 4 lines, but 2 lines is enough for you to find the center. So this is your center, and your scale factor is negative, and it become bigger 3 size, right? Okay, you see this one 1, here is 1, 2, 3. So it's bigger, bigger 3 times bigger. So this one, you need to write down enlargement and scale factor negative 3, and your center is negative 3, 2. Okay, 3 marks here, so 1, 2, 3 here. Okay, part C, transformation T is represented by the matrix. Okay, so now you want to know what kind of matrix is this, right? So again, you need to know your standard 1, 0, 0, 1 from your graph 1, 0 and 0, 1. And this 1, 0, right, goes to negative 1, 0. Negative 1, 0 is here. Okay, and your 0, 1 goes to 0, negative 1. So it goes here. Okay, so this one go here, this one go here. So it is a rotation, right? It's a rotation of 180 degree. See this? This one go here, this one go here. Okay, so we want to rotate this 180 degree from A until D. Okay, and your A is here. You want to rotate 180 degree through the origin, through the origin here. So what you're gonna do is, okay, I erase all this. Okay, this one, you draw a straight line. Okay, from here until here. Okay, you draw a straight line, then you count the number of boxes. Here got 5, here also got 5. So this point will go to this point. Okay, and then for this point, also the same. You draw connecting until 0, 0. You get 6 boxes, and then you draw another line until here. It will be 6 boxes as well. Okay, you see it's a straight line. Okay, same length here. These two same length. Okay, we have 2 points already. Okay, the third point here, same. You draw a line until here. Okay, it will be the same one here. Okay. Okay, the green one just now. Where is it already? The last one, this one. You draw until here. You use the ruler better, then until here. Okay, you see it's a straight line. So it's actually rotate 180 degree because straight line 180, right? So okay, I have the point here already. Then I draw the shape. So this is shape D. Okay, so that's the answer for part C. They didn't ask you to describe, but if you need to describe, the answer is rotation 180 degree. Okay? Okay, now let's look at question 7. Draw the image of shape A after a translation of negative 4, 1. Okay, negative 4, 1. Okay, so I'm gonna move this negative 4, means that to the left, 4 step. 1, 2, 3, 4. And then 1, go up 1. So it's here. Okay, so this point will go to here, 4, 1. And then this point will go to 1, 2, 3, 4, and then go up 1. Or you can actually just follow the shape. You see this one like this, right? Then this one is 2 step like that, and then 4 like that. Or you can always count the box now. 4, 1. Negative 4 means go to the left. 1 means go up 1. And then here we'll go to here. Okay. So this one is label. They didn't ask you to label, so just write part A. Okay, this is the answer for part A. Part B. Draw the image of shape A after an enlargement with scale factor negative 1/2 with center half, center 1, 0. So let's look at the center first. Center is at 1, 0. 1, 0 is here. Okay, the one that I center 1, 0. Okay, so enlargement scale factor negative half. This is your A. Negative half means negative is the opposite direction, and half means it becomes smaller, one size. One size smaller means divide by 2. The size become divided by 2. So the purple point, there are 4 points here, right? This purple one. Okay, 1, 2 until center. So your center to image will be divided by 2, which is 1 only. So it's here. Okay. And as for this one, 1, 2. So divided by 2, so only 1. Like that. Okay. And the green one here, there are 4. 1, 2, 3, 4. So divided by 2 become 2 box. 1, 2. So it's here. Okay. And the last one, this one. Okay, here until here 4 box, right? 4 box divided by 2, so 2 box only. So here will be 1, 2 until here. Okay. So I have all the 4 points already, so I connect them. So this is part B answer. Okay. So part C, shape A is mapped onto shape A is mapped onto shape B by the single transformation P. So this one is reflection. Okay, it's like mirror. Huh? So your mirror line is here lah. Okay, so it's obviously reflection. So the answer is reflection on the x-axis. Or if you write y equals to 0 also can. Okay, this line is y equals 0. Okay, find the matrix representing transformation P. So you need to write down the matrix that represent reflection x-axis. Okay, let's say you cannot refer to the answer, to the notes, right? So what you do is, always go back to the original 1001 and then you reflect these 2 points. Okay, 1001 will goes to reflection of x-axis. This is your x-axis. 10 will still be 10. Okay, 1 here will go to here, reflect. It will become 0, -1. Okay, so your answer is 1, 0, 0, -1. Okay, that's all for my explanation here. Okay, I want you to double check your matrix because I check your work. Some of you still copy wrongly. Okay, and I want to discuss also with you the questions that I asked you guys to do last time, right? Okay, so check your answer also lah at the same time. Okay, so translation again is always 2 by 1. This is called column vector. Okay, it's in the form of matrix as well. Okay, question 2, this one, example 2. Okay, please double check again. Make sure it's not wrong here. And question 3, question 4, question 5, 6, 7. I think this is the question that I asked you guys to do, right? Question 8 and 9 is K00K. Okay, so now let's go to the new topic now, vectors. Alright, so welcome to Vectors chapter 8 in your 4B book, the new book. Okay, so I start off with 8.1, Introduction to Vectors. Okay, so before you need to know what is vectors, okay, you also need to know scalars. Okay, scalar and vector. What are the difference between scalar and vector? Okay, so let's look at this example. Okay, I give you an illustration here. Okay, this line, right, A to B is 8 meter. This line also A to B 8 meter. But then here I add on with the arrow. Okay, you see the arrow here and you see a 60-degree bearing here. Okay, so what I can say about scalar is AB, right, has a magnitude of 8 meter. Okay, magnitude you can relate it with distance. Okay, so scalar is all about magnitude. Okay, it's all about magnitude, which means in this case, the distance of AB is 8 meter and it's called scalar. Okay, it's called scalar. And as for vector, okay, you can see it's also magnitude. Magnitude means can be something like distance, okay, but also include the most important direction. Okay, the most important one, direction. You can see this by just looking at the arrow. Okay, you want to know whether it's vector or not, you can see if it has an arrow, confirm vector already. Okay, because it shows direction. Okay, both also magnitude. Okay, but one with direction. So the one with direction we call as vector. Okay, so the simple one example for scalar is normal distance, because distance we don't look at the direction. Okay, distance AB, BA, it's the same. A to B is 8 meter, B to A is 8 meter. So no matter what the direction is, it's still a distance, right? And then for example also mass is also example of scalar because it doesn't include any direction. And speed as well. You see speed, no negative, means that it doesn't include direction for speed, right? And example for vectors are velocity. Okay, velocity include direction because you will have negative velocity when you have negative displacement. Okay, negative displacements means you are going anti-direction. Okay, for example, A goes to B is 8 meter, but B go back to A is -8 meter. when we are talking about vector. Okay, so velocity, displacement, even acceleration also. Okay, I don't want to write too much. Okay, just a simple one only. Okay, so when I say vector, this one, I will say A goes to B. Okay, A goes to B with the direction of bearing 60 degree. Okay, and which is also magnitude of 8 meter. Okay, and we call that as vector. Okay, so let's focus on vector. Okay, so when we say vector of AB, okay, in this case, written as this, AB with the arrow AB. So this one, we read this as vector AB. Okay, vector AB. And sometimes it can be also written as, okay, let's say it's A with the curve at the bottom here. Okay, the curve sign at the bottom here. Okay, which we call it as vector A. Okay, so it can be also written as vector A. Okay, in your textbook, okay, in your textbook or in your question, it's often written as bold A, and then it's bold. If we write it down, it's hard for you to write down in bold letter. Okay, so instead of writing in bold letter, we write A with the curve underneath the A. Okay, so this is how you write your vector. Alright, so AB means A to B. Vector AB means A to B. The arrow from A to B is A, denoted as A. Sometimes it can be B. Okay, remember there's a curve underneath the B, or it can be C, and so on. And when we want to talk about the magnitude, right? Okay, the magnitude basically is the distance here. Okay, so if you want to write down the magnitude, it's often written as this. Okay, this is called magnitude of AB or distance of AB. Okay, this is magnitude of AB or distance of AB with the modulus bracket, this bracket, like that one. Okay, and then it's also equals to 8 meter in this case. This is called magnitude. Your distance, 8 meter, is your magnitude. Okay, or sometimes it can be written as vector A with the modulus. Okay, with the modulus equals to 8 meter. Okay, or you can, it also can be written as length or distance. Okay, or magnitude. Okay, they are the same. Okay, so this is how you write your vector. However, okay, your AB without the modulus, okay, it is not 8 meter. It is not, okay, because 8 meter is the magnitude itself. AB is a vector. Remember, vector must come together with direction, right? 8 meter doesn't show the direction. It only shows you the distance or the length. Okay, remember, magnitude is not the vector itself. Okay, so AB with the arrow there, it means vector of AB is not equals to 8 meter. Okay, if you want to write down as the 8 meter, you must put the modulus which represented by magnitude. Okay, remember that, Now I want you to look at this parallelogram. Okay, this is a parallelogram. Okay, so it has two pairs of parallel lines. Okay, AB is parallel with DC and AD is parallel with BC, right? Okay, and then the line of DC and the line of AB, they have the same length as well. This AD and BC, they have the same length as well. Okay, so this parallelogram has two pairs of parallel lines, and it has two pair of same length. Okay, so what we can conclude here is, okay, here got direction one, you see, this one, this arrow, this is an arrow from A to B, this is arrow from D to C. Okay, AB and DC, they have the same length. Okay, same length, and they are parallel. So from what we can see here, we can say that the vector of AB is equals to the vector of DC. Okay, AB to DC, they are the same. So meaning to say that if they have the same magnitude, or if they have the same length, and if they are parallel, So, or they have the same direction, okay, because they have the same direction, right, like that. So we can say that they have the same vector, right? How about BC and AD? AD will be equals to BC. It's the same, huh? So you can see the arrow A to D, B to C. Okay, what if AB, DC, right? Can I say AB equals to CD? A to B, you see the vector of A to B, I put the arrow, right? Is it equals to C to D? They are not equal, okay? Why they are not equal? Because different direction ba. CD ma, CD going entire direction is not the same direction. So this is not equal, okay? So vector must be same direction. Okay, these two vectors which are equal, okay, which are equal means that I'm talking about these two equal vectors, must be same direction, must be same magnitude. Baru, you can say that these two are the same. Okay, so these are the important things that I want you to know in vectors. Okay, I conclude that vector must be magnitude and direction. Okay, must be magnitude and direction, include these two, and it's denoted by A, B, and then with an arrow on the top. Okay, and then it can be written as A with the curve sign below the A, or it can be B. Okay, and then AB with the modular sign. Okay, with this kind of bracket, we call it as magnitude or distance or length. And vector AB cannot be 8 meter, it cannot be a distance, okay? And if you have parallel line, okay, same length, then we can say that the two vectors are equal, okay? It must be same direction, A to B, D to C, A to D, B to C. I give you the example that is not the same, okay? A, B, C, D, not the same vector, okay? Or I say B, C is not the same vector as DA. Okay, BC, DA, terbalik, cannot, they are not the same. Okay, please take note on this. Now let's look at column vector. Okay, so vector, right, it can be represented by column vector. It can be written in a column vector form. Okay, why column vector? Because column vector actually tells us the direction. Okay, tells us the direction. If you remember what is column vector, you have seen this in translation, okay, under transformation. So column vector can be written as 2 by 1 matrix. 2 by 1 matrix as in the top one is X, the bottom one is Y, which X is represented by left right, okay, left or right, and as for Y is up down, okay, and negative to the left, and if go down is negative. Okay, so left, right first and then up, down. So this is column vector, right? So vector can be represented by column vector. Now let's look at part A. This is vector A. You can see that it's a bold A. It's a bold A. Or if we are writing it down, because we cannot write in bold, right? So instead of writing in bold, we write a curvy sign at the bottom. Okay, we call this tilde. Okay, tilde sign. Underneath the alphabet, okay, but I will call this as vector A. Okay, we call this vector A. This one is vector B. Okay, this one with arrow confirm called vector already. Vector of PQ, vector RS, vector TU, and vector XY. All right. So let's look at vector A. Vector A here, right? Yeah, this is try it one, page 54 in your 4B book. Remember, this is 4B book, not 4A. Okay, let's look at vector A. Vector A here. The arrow is from here until here, right? It's going this way. So our column vector here, part A, column vector here represented by XY. So it goes to the left first, okay, with 3 steps, so negative 3, and then go up 1 step, so negative 3, 1. Okay, so this is your answer for A. And for your B, this one is going to the right 1, 2, 3, okay, and then going down 1. Okay, so vector B going to the right 3, going down 1. Okay, I think this one you guys are already familiar with because you already do the translation, right? Okay, and then for part C is PQ, vector of PQ. P to Q, you look at your P to Q, the arrow is P to Q. So it doesn't move left, right, so it's 0. It's going down straight away by 3 steps, so negative 3. Okay, this is the answer for part C. Right, part D. D is R to S. R to S here is going to the left 2 steps and going down 3 steps. Okay, so R to S is negative 2 and negative 3. Okay, and part E is T to U, going to the right 1, 2, 3, 4 step and does not go down or up. So E is 4, 0. Okay, and as for your F, which is X to Y, okay, it's going to the right first, left first 1 step and going up 1. So going to the left is negative, going up is positive. Okay, so this is for try it 1. Okay, so try it 1 is to tell you the direction by column vector. Okay, so we will often see column vector in this chapter. Okay, column vector as in 2 by 1 matrix is a 2 by 1 matrix, this form. Right? Okay, let's go to try it 2, page 55. Okay, page 55 here. Okay, so in the diagram, A, B and HK are 2 vectors. Okay, we can see that these 2 are vectors. Okay, so express A, B and HK as column vectors. Okay, this one I think you guys know. So A, B, A to B is going to the right 3 step and going down 2. So it's 3 and negative 2. This is answer for part A for AB. And for your HK, okay, you look at the arrow. HK is going to the left first and going up. So it's negative 3 and positive 2. Okay, you see this? AB and HK, they are different. Even though you see this one, right? They are parallel. The direction is different. Okay, in vectors, direction matters. Okay, remember, direction matters because the arrow from A to B, like this, HK is different arrow. But if the arrow is the same, let's say, right, like this and like this, they are the same. So the vector of AB is equals to KH. Okay. Right, so that is part A. Part B, we need to find the magnitude. Okay, before finding magnitude, let me explain a bit on AB and HK here. Okay, you have AB, HK, right? So basically, you can see that AB is equals to negative of HK, right? Because if this one is negative of this whole thing, this one will become positive 3, same, right? And this one become negative 2, it's the same. Okay, so AB is actually equals to negative of HK because it's the anti-direction of the AB. Okay, and you can see that AB here is actually equals to KH. Right? A to B, KH going this direction. Okay, or you can say that AB is equals to negative of HK. Okay, AB is equals to anti-direction, negative, going the opposite direction of HK. But AB is not equals to HK. Okay, the vectors of AB and HK, they are not the same. Okay, they are not the same vector. Okay, how about magnitude? Okay, in part B, magnitude in this case means distance, the length. So how are we gonna find the length, right? How to find this length of AB? You can see that this can be formed into a triangle. This is 3 units, this is 2 units, right? So if this is a right angle triangle, we can find this length. Magnitude means we are finding the length by using Pythagoras theorem. Okay, so 2 square plus 3 square, square root, and then you will get this AB. Or, okay, the formula for the magnitude, okay, magnitude is written by this with the modulus sign or absolute sign. We call this absolute value or modulus. Okay, this kind of bracket we call modulus. So which means magnitude. Okay, or we can call that as distance. Okay, so distance here, the formula is x squared plus y squared and then square root. So this square plus with -2 you square and then you square root. Actually, it's the same as this, isn't it? 3 square plus 2 square and then square root, right? It's the same. So if you're not given any diagram, if you're given only like this, right? If you're only given like this, you just use the x square plus y square and then square root. Okay? So this one will become square root of 13, which is 3.61 units. Okay, magnitude of AB. And next is magnitude of HK. Magnitude of HK, okay, if we don't look at the diagram, we just look at this. What we do is x squared plus y squared. So basically after you square, you will still get a positive. So it's actually the same thing, right? 3 square plus 4 square. Okay, and if you're looking at diagram, it can be formed into a triangle as well. This one 3 units, this one 2 units. Okay, it's the same, right? So actually they have the same magnitude. Same magnitude but not same vector. Okay. Same magnitude means they have the same distance. So this one also square root 13, which is the same as your AB magnitude. Okay, so they have the same. And direction. Okay, how are we gonna write in direction form? Okay, we can actually show, okay, this AB is going downwards. Okay, it's going downwards. So the direction of AB is going downwards. Okay, I'm writing it down. Downwards with the gradient of y over x. Okay, this is going down. Okay, it's the gradient if like this, right? If it's going like this means it's a negative gradient. Okay, positive gradient is like this. Negative gradient is like this. Okay, so this is negative of y over x. Your y is 2, your x is 3. So the gradient is negative 2 over 3. And HK, right? HK is going upward. Okay, the direction is going upward because of the arrow, but the gradient is also negative. They have the same gradient actually. You can see it's a parallel line. Okay, but the direction shows that it's a downwards with gradient. This one is going upwards with the gradient of this. Okay? Remember, positive gradient is like this, going up. This one, it doesn't mean going up, okay? This one is upwards direction. Okay, so we have done part B. Now look at part C. Is AB vector equals to HK vector? Do they have the same vector? No, because you can see here the column vector here is obviously shown that they are not the same. So AB is not the same vector as HK. However, the magnitude is the same. This is just extra, but then this is the one that asking you. They are not the same, no. But magnitude, this one I add on only to show you they are the same. Okay. Alright, let's look at your homework. This will be your homework. Okay, page 56, question number 2. This one, copy the question. Question number 2. Okay, so this one, find the column vector. I think you can do the column vector. You can refer to my try it one. And find the magnitude. Magnitude, I teach you how to find magnitude already, right? After you find the column vector, use the formula that I teach you. Okay, square, actually it's a Pythagoras theorem. If you insist to use the formula, this is the formula. Okay, where your column vector is x on the top, y at the bottom. Okay, find magnitude is this. Okay, and then write down the vectors which are equal. Okay, after you found the column vector, you can tell me which vectors are equal. I can tell you from the diagram given here, it's a very obvious one. This one and this one, they have the same vector. Why? Because the direction is the same. The arrow also the same. Right? Okay. Number 2, you do as homework. And number 5 also as homework. But number 6, I will teach you how to do. And please copy this down, question number 6. Okay, I will be doing question number 6 for you to see. Okay, so CD equals to this. This is column vector of CD. This is column vector of ST. And find the two possible value of P if, okay, this is magnitude of CD and equals to magnitude of ST. Okay, magnitude of CD is equals to the magnitude of ST. Magnitude of CD is, okay, equal sign in the middle, so I'm not going to write down equal sign at the side. Okay, square root of x squared, this is your x, this is your y, 0 square plus 13 square, 0 square, no need to write, also can. And square root of negative 5 bracket square plus with p square, x square plus y square. Actually, right, if you have this kind of vector, 0 and 13, we can know that the distance is 13. Okay, how do I know? Because it doesn't go to the right or left, it going up straight away 13 step. So the distance or the length will be 13 units. Okay, but if you don't understand what I'm talking about here, okay, you can see this. I can show you why is it 13. After you square, you will get 13 square, which is 169. After you square root, you will still get 13. Okay, so this one I'm going to straight away write 13 equals to negative 5 square plus p square square root, and here I will find the p square. Square root move over become square, and this one will become 25 positive plus p square. Then I move my 25 over become minus. So 169 minus 25 is 144. So my p is, I move the square, becomes square root. So square root of 144 plus minus. Don't forget, if you have square, if you move over become square root, become plus minus. So it's plus minus 12. So the possibility answer for p is 12 and negative 12. Okay, two possible value of p is this. Okay, that's for number 6. Okay, so your homework. Okay, please try to do question number 2 and number 5. This is exercise 8.1. Page 55-56. Okay, so that's all from me. See you guys in next lesson. Bye.